pleased this afternoon to start off our afternoon session with Sue Ann Hatherley. I think everybody here knows her. She's been talked about in every book that's been published about Green Bank that I have ever read. She really has made it possible for SARA to come here through the years. Without her support, her sponsorship, we would be somewhere else and not here. But you have made this a real home for us, Sue Ann. We appreciate it, and we're eager to learn more about your educational programs.
Thank you so much for the opportunity, everybody. And my first piece of news for you is that in December of this year, I'm retiring.
Oh, congratulations.
I say I'm quitting. I'm not retiring because that just sounds like I'll do things. I'll probably come back and still say howdy to you all too. And I'm going to become what Skip was, which is a volunteer science ambassador here. So I can say yes or no, depending upon what I feel like doing to help out. But yeah, I am. And I can't believe it. When I say it out loud, it kind of makes me nervous to see you say it. But I have to say it out loud and get used to it. So I wanted to tell you all that too. And we're super happy to have people that love radio astronomy as much as we do here come visit every year. So Sarah, you always have a home here as long as you want it. So I'm going to talk to you a little bit about some of the educational public outreach things that we do here. And I adapted the talk from the talk that I have to give to the National Science Foundation every year because we have a meeting where we justify our existence every year, and I'll stand up and talk about education and public outreach a little bit. And so that'll be the basis for the talk. But you know, a lot of you all are involved just by virtue of the fact of building things and doing astronomy as so-called amateurs, and I'll put that in quotes because you know a lot of electronics, but doing things in that sense of being an amateur, you're kind of a public outreach group anyway. If you think about it, if you share that knowledge with somebody else, like you're doing right here, you're doing education and public outreach, in my opinion. So I think of you in that way as well. So first of all, the observatory has an education and public outreach goal, and that's essentially to inspire the next generation of workers that will come here. We want to inspire the next generation of engineers, the next generation of scientists that will work here, and all of the associated jobs that are here. But in addition to that, we just want to inspire the public that it's important to do science, and it's important to support science in our country, and they should feel proud that our country supports new knowledge creation. And so we try to get that across to the public, that it's cool, that the Green Bank Observatory is great, and it's well worth a few tax pennies to do it. So those are our main goals in education and public outreach. What I'm going to be talking to you about today, I'm just going to skim through news and media because we do a lot of things online that we didn't do before the pandemic. You know, we do virtual tours now. We're still doing them even though the pandemic's over because people from around the country can't get to Green Bank and they want to know what we're up to. I'm going to talk to you a little bit about our public outreach and our visitor programs that have been going on since well before I came here in 1989. And then what's nearest and dearest to me is our K-12, our K-16 educational program. So one thing that I want to let you all know, do you know about our community Zooms? About once a month, we have a community Zoom. And I'm going to click on the link here at the top here so you'll know about it. But you can ask to join. And every month, there's a little address, usually by the director, about the status of the observatory, what's going on, a little bit of news and updates. And then somebody will get on for about a half an hour and just talk about their science. So if you want to join the community Zoom, please do so. Has anybody done that before? Anybody joined us for that? So it's a website. You can find it there. Oops. Let's see if I can, did I get there? Oops, here it is. greenbankobservatory.org/science. And it's just a science community webinar. And you can see sort of what the little talks are. They're very informal. You can sign up for invitations and a link is sent out about a week before every Zoom to you, and you can just click and register for it and join us. So please do that. I think you all would enjoy that. There's the cursor.
I'll put that in the journal.
Okay.
Next journal, we'll put that on the site up and you guys can look at that.
Yeah. We also do a lot of, anytime we have a meeting, it's similar to the way you're having a meeting right now and you're recording everything. We record the sessions of those meetings and we put them on YouTube. So if you're looking for in-depth things about astrochemistry or SETI or anything that we might do a workshop on, you'll be able to find all those talks and videos from that on our YouTube channel. Now, yeah, this is just an example of some of the things that you might find on the YouTube channel, everything from planetary radar astronomy to the community Zooms. We always put those up there, and pulsar research with Maura McLaughlin, just all sorts of things like that that you can find on our YouTube channel. Basically though, the programs that I have developed over the years or support over the years kind of follow this pyramid here, where we do programs for families and the public. Back when I first started, I gave public tours of what I call a prison bus. It really looked like a prison bus. It was so loud, there was no air conditioning, and I tried to microphone and give a tour around the site. So I've been doing that since the very beginning. We've been holding family events since the very beginning as well. So an open house, things of that nature every year. And so we like to do as many fun things with the public as we can. K-16 programs that I'll talk about a little bit include our overnight program. We call it Be a Radio Astronomer for a Day. So when I first came to Green Bank in 1989, I was a teacher. I was teaching science. And I came here, it was in 87 actually, as a teacher for 2 weeks. And they had just gotten this little old rinky-dink telescope working called the 40-foot. So it had been kind of sitting around doing nothing for a while. And an engineer at the time said, I'll see if I can, string it back together. And they gave us access to us. And we did little projects. And so my project was to look at the right ascension range of around 12 hours and 30 minutes and a declination of around 12 degrees and see what was out there. And we were inspired by the 300-foot at the time, my little group. And the 300-foot was nodding up and down a lot. And it was collecting data as the Earth rotated, just by collecting strips of data and recording where the signals were coming from and making these large maps of the sky that would then be followed up by the BLA scientists or whatever they wanted to do. And so we decided to do that too. And we nodded the telescope up and down and up and down. And I discovered this beautiful big radio source that was coincident with being pointed straight up. Every time I would nod the telescope from one limit to the other, this beautiful hump would appear straight up. And I took my chart recorder paper down and I ran to the astronomers and I said, look at what could this be? I mean, it had a huge amplitude. And they all just kind of smiled at me and said, that's very interesting. Did you go back down and see if you could see it at another time? I said, no. Well, maybe you should try that. So I went back down at a completely different time, scanned the telescope from limit to limit, and lo and behold, this beautiful hump appeared over the zenith again. And so I discovered the Earth. It was one of the things I discovered first time here at the observatory, because we were getting spillover from the ground. I was picking up thermal radiation from the ground, but I didn't know that. I didn't know a megahertz from anything when I first came here. But what that experience gave me was the feeling of being a scientist, of discovery. I didn't know what I was going to discover. These signals showed up on my chart paper, and it was our job as a team to try to make sense out of it. And we didn't do it by Googling. We did it by thinking about it and just coming up with silly ideas that weren't silly to us at a time. And that made me go back and change the way I taught. It changed the way I taught. And so inquiry-based education has been something that I feel deeply, and I try to interject in all the EPO programs that we do, including Radio Astronomer for a Day. So if you're going to be here for 24 hours, we can give you a little bit of that experience by teaching you how to use the telescope, sending you out there to collect some H1 spectra, because those are fun and easy to get. And then we'll talk about what do you see in that data the next day. And that's the hallmark of a lot of our K-16 programming. But, not everybody can come here and be a radio astronomer for a day. And so we do some other things as well that are more out there, outreach, as opposed to education things that we do here. This K-16 residential programs that I'll talk about, we just finished a whole month, 30 days of 14, 16-hour days working with youth here. And I'm still exhausted from it. So if my words don't come out right, it's because I used them all up in the month of July, and I don't have very many left. And then we do some things for undergraduate students, all by themselves too, the research experience for undergrads. I'm going to tell you specifically about a research experience for teachers program that we were part of. It was based out of WVU, in which teachers built horn antennas. I know you're all building antennas and using SDR, and wrote about it in enough detail that 8th graders can build them now and use them. The 40-foot was broken during one of our camps for the first week, and so we said, let's build horn antennas. Let's see if they can do it, and let's see if they work. And they all did. We all got H1 spectra, and they were all so pleased with themselves after doing everything from sawing boards to soldering antennas and things like that. So the group that started that, as teachers, they probably didn't know as much radio astronomy or technology or theory as you all do, but they, through the building of them and documenting that and iterating year after year, they've really come up with a set of instructions that just work. They work. We've got the little software that goes with it, etc. Sounds similar to what you're going to show me later on, and it works. And so you can take this out then and make instrumentalists out of kids, you know, and that's what we did this year. Okay, so first of all, for public outreach, and again, this was these numbers are based on not this past year, but the year before, because I haven't compiled them yet for this year, but we are bouncing back from the pandemic still to this day, and we give a lot of science center tours, and we see about 40,000 visitors a year at our science center just across the way there. I need to fix this one because we're not half capacity anymore, and you don't have to have a vaccine anymore, but we are we're back from the pandemic. 40,000 a year is about what we saw before the pandemic, and they get a public tour. So they get to get on the bus and go down. They get to put their cell phones in a Faraday cage. They get to experience, you know, what we do and trying to make it radio quiet around here so that we can do our science. And Angela Damery is the person you might be dealing with next year and setting up your time here. She's the director over there of the public outreach program. So this is sort of the public facing program that we do, including Radio Astronomer for a Day and how it breaks down. So we do fewer virtual visits than we've done in the past, but we still reach a lot of people through a virtual field trip. Sometimes it's a virtual using of the 20-meter telescope, and that's something we try to do to be engaging with a group. And then this shows you the sort of how we break down our in-person visits by different groups. So we see a lot of kids. We do a lot with the public. We also see a substantial number of undergraduate students that come to visit for a weekend as part of a college group. These are the kinds of community EPO events that we do. We engage with the local community through the science fair. We host the science fair every year down in the basement of the science center. Go down in the basement of the science center. Go snoop down there. You're welcome to go snoop. You're going to see about, I don't know how many thousands of boxes down there right now, because we agreed to work with the Astronomers Without Borders folks and accept eclipse glasses, used eclipse glasses from April 8th, that we are going to vet and then ship out to places like South Africa. And I know we have over 1 million glasses down there. It's just crazy. It's ridiculous. We never thought it was going to be as big as that. But go in the basement and see that. We'll have to get them cleared out before science fair because we hold the science fair down there too. And we need to have that space. And then we do an open house every day. The local rocket club comes and helps us build and launch rockets as part of that. So those are fun events that we do to not only for the kids, but just to engage our local community in mutually happy events so that they don't mind living without their cell phone because the kids are getting something good from the observatory as well. We want to have good relationships with them. And those are just some examples of events that we put on last year. All right, well, let's get to the stuff that I really love, and that's our K-16 programming. And this little arrow here is meant to show you sort of a progression of different things from youngest to older people that we engage with. So at the bottom, we have a partnership with the Franklin Institute. We essentially train librarians and folks like that to do some hands-on activities with their community folks that are all sort of NASA themed or Mission to Mars themed or Artemis themed. And the activities are by and large given to us. We don't have to invent them, but we are a hub here that then, you know, reaches out to libraries and community-based organizations in our area. And amateur astronomers are part of that too. So there's no reason why amateur radio astronomers couldn't be a part of it. These are mostly amateur optical astronomers that drag out telescopes and show people the night sky, no matter what the, you know, whether it's light polluted or not. They're just out there to do that. West Virginia Science Public Outreach Team is a program I'm going to spend a little bit more time on. But as we go up through these two here, Physics Inspiring the Next Generation and the Governor's STEM Institute are our residential camp programs right here every summer. They're here for 2 weeks and they do research. The Pulsar Science Collaboratory, I think you're going to hear more about a little bit later from somebody, but we started that in 2007, working with astronomers at WVU to engage students in analyzing GBT data, discovery data, to search for signs of brand new pulsars, rotating neutron stars. And our students have discovered a few over the years, and they were here last week doing advanced projects using the 20-meter telescope. So that's something we've been doing since 2007, really. Okay, well, let's talk about our undergraduate internships. Every year we have about 10 undergraduates working here with different astronomers. It's called the Research Experience for Undergrads program. And we start out with a boot camp here every summer where we introduce radio astronomy to everybody. And so these are students not only here at Green Bank, but from the VLA and also from Charlottesville that all come together in Green Bay, because this is a great place for a workshop to learn radio astronomy basics. They use the 40-foot. They report on projects at the end of the week, and it just gets everybody on the same page before they embark on their individual projects with a mentor here or abroad. These students right here were part of a 2-week internship, and you can see that Horn Building was part of our program there. And so they were working with an astronomer on a new receiver that we've got called the ultra wideband receiver. I forget exactly how wide the band is, but it's several gigahertz wide, and it's centered around, you know, L-band. And the idea is that with such a wide band, they want techniques to get better at almost near real time RFI excision, and they're using a technique called cyclic spectroscopy to look at signals that might mimic, that have periodicity to them, but we don't want to get rid of pulsar signals, for example. And so these students were all analyzing plots that came out of this cyclic spectroscopy thing. That was their internship part. That was what they were doing as part of the program to get this ultra wideband receiver working. But as an additional part of it was to build their own receivers there. So they did that too with their own antenna. Okay, let's talk about this pulsar collaboratory thing. Back in 2007, we had new pulsar astronomers join the WVU physics department. Their names are Maura McLaughlin and Duncan Lorimer. Has anybody heard of either one of these two? Okay, so they received the Shaw Prize this past year for the discovery of fast radio bursts. But they've done much groundbreaking astronomy and pulsar astronomy. So not only did they discover the first burst, but it's called the Lorimer burst. but they just do amazing pulsar research, and they are leaders in the team that discovered this stochastic background of gravitational waves by looking at pulsar signals, by timing millisecond pulsars. So back in 2007, before they had done all this groundbreaking stuff, they were pulsar astronomers and they joined WVU, and we wondered if we could do something that was more interactive than SETI at home. You remember SETI at home? This is that program where you give over your computer, your CPU, and they analyze data with it, and maybe would discover an alien signal or something like that. Well, we thought, wow, if there's enough data available to students and they could learn how to be responsible data analysts, could they be involved in hunting for new pulsars in survey data? And this is the kind of data that they get, that they have to inspect and grade essentially for potential to be a new pulsar. And we're still doing this to this day, even though we've got AI and all this stuff. You put things through algorithms and then let's have some eyeballs on it. And so our students are still doing this to this day as sort of their first level of pulsar research. And we started this in 2007 with an NSF grant. So many students now have been exposed to scientific research, a research community, because they interact directly with Mara McLaughlin. We have webinars and we teach students how to do this, and they interact directly with the scientists in the cutting edge of pulsar astronomy all the time. So that's been going on in some guise or another since 2007. Does anybody have any questions about that or other things? You just feel free to just, yeah.
Yeah, I do. I was curious about, I was able to get some students to participate in this specific initiative, but I noticed you had to be either a teacher or a student. What if you're not a teacher? And so any of these projects or initiatives that you're talking about, if there's opportunities for non-teachers or non-students, AKA like me, to participate in anything like that, feel free to bring that up too.
I will, and I'll tell you this, we don't do any non-student, we don't do citizen, it's not a citizen science project. This one probably comes as close to being a citizen science project as there is, but you have to be a leader of other students. It's really a student-based project with teachers participating as well. Now, you don't have to be a certified teacher to be considered a teacher, but you have to be a mentor to a group of students. It's not just say, I'm going to look at this data and find new pulsars. It's to engage students in this research community. So if you can meet those sort of standards, then absolutely.
Like if you did a science
If you were a club, yeah, absolutely, absolutely.
Or a volunteer at a school.
If it were a sanctioned volunteer at a school and you're going to run this group of students, or just see if, I think Tom's going to talk to you later. He's coming here to talk to you, and he is one of these people. Oh yeah, so yeah, he is a person that's not a, employed teacher at a school, but he's working in that capacity. And then we'll be happy to have you join us, because we need, people to just mentor students as they go through. All right. So the whole purpose of the Pulsar Search Collaboratory, as it was called for years, it's called the Pulsar Science Collaboratory now, is to create a science identity in students. So if you're a student and you're thinking, wow, I could be a scientist when I grow up. I feel like one. I think I could do this. You're kind of trying it on with something like the Pulsar Science Collaboratory, or like I did when I came here in '87 and used a 40-foot. I felt like a scientist. And the scientists weren't going to tell me the answers. They didn't say, oh, you just picked up the ground. They said, go back. Are you going to see the signal again? What can you do to test your idea? And engaging students in this way really kind of builds that science identity in them. And so the PSC has that as its educational goal. As its science goal, we have the goal to do some pulsar science. And nowadays, students engage in advanced projects. So we have a student group working on scintillation projects. We've got one tracking giant pulses from the crab pulsar using the 20 meter. And so they're working on advanced projects generally led by a graduate student or an undergraduate student, and they get to be co-authors on any papers that might come out of it. So it's kind of lower level, real research, but lower level research that Mara and Doug don't have time for anymore, that these students are engaging in. But there are some parts of it. We have an online workshop twice a year. We have one in the fall and one in the spring. You can do the online workshop asynchronously. You don't even have to be a part of it, but twice a year on Thursdays at 7, we have invited speakers. And so you get to start to network with other PSC students. You get to network with other scientists that are doing pulsar research. And so we do that twice a year, and it's 6 sessions. And the learning how to be a pulsar data analyst is done more or less on your own, and we discuss it on these web chats every week. We have capstone seminars at WVU. So if students have met a certain criteria, that is, they have certified to be pulsar data analysts, they have analyzed enough data, then they can be invited to capstone or to PSC camp, which is what we just held this past week. So it's a week long. Students come back because they kind of want to be astronomers maybe when they grew up, I think, or they really want to investigate it. And they come back and work on these advanced projects together. And we had 20 students. We are now, this was funded by the NSF for many, many years. We are attempting a model now where we don't ask for NSF funding to do this. So students who can, they pay for their room and board to be here. And students who need a scholarship, we try to give them one. And we get that scholarship money from the big black funnel in the lobby at the Science Center. So go put a quarter in there and let it spin around. But that's one place where we get some money to be able to do that. And this is good. It's good to try to do things in a self-sustaining way. But the results have been fantastic with this program because students feel like they're contributing to science because they are, and they feel like scientists because they are, and they're part of a community of scientists. And so this has been really successful since all those years ago. And that upper right picture is a plot that was analyzed by those 4 students and one other, and it turned out to be a new pulsar. And so they got the credit for that. Okay. Now, when I was a teacher here and I used the 40-foot telescope and I had that wonderful experience, I just want to give that experience to others. And that's where the West Virginia Governor's STEM Institute and PING both come in. These are both for rising 9th graders. They spend 2 weeks here. They do these open-ended projects. Yes, the answers exist out there, but they don't know that. And we don't care what answers they come to, as long as they are using evidence to back up what they say. So a typical project they might do for 2 weeks would be to do similar things to what I did, to investigate a mysterious region of the sky centered around a particular coordinate and see what you can learn, or investigate nebulae, or investigate to see if 40-foot can detect hydrogen from other galaxies. You just put a question out there in front of them and they can take it from there. So over the course of 2 weeks, they collect a lot of data, they analyze the data, and they report on it at the end in a colloquium, which is pretty cool for an 8th grader to stand up and say, be part of a research team and really acquit themselves as scientists at the end. I mean, they just really do an amazing job. We do a lot of other stuff too. We do a lot of other fun stuff. It's not just all research. So we're always doing science Olympiad things or art or what have you, bike riding, what have you. It's fun. But the main thing is to do this research project. All right. Mission to Mars is a program that we got engaged in with Franklin Institute, as I said, and amateur optical astronomers. So sometime in the future, maybe we would think about what could we get involved in that would have amateur radio astronomers as part of it. And this digital signal processing group, these teachers that started the Horn building, might be something for you all to join, because if you're experimenting with new antenna techniques and stuff like that, this is a great group to get engaged with and get some students involved in building antennas too. I think that's really great. And then the science public outreach team is really amazing. It is the Green Bank Observatory, bringing students in from higher education institutions around the state. They come in here for training on how to be a great outreach ambassador, how to give a great interactive presentation, how to engage students in hands-on activities, and they learn presentations that we have already created. And we've created these presentations because A, it furthers our aims. It might be a radio astronomy presentation, but it might also be a presentation on environmental science. Why would we do that? Because the researcher at WVU had a broader impact piece to their grant, and they will support us to develop that with them and train undergraduates to do it. So we will do, if it's STEM related, we might take that on. So we have maybe 30 undergraduate students on any given year who come to Green Bank to receive some training. They learn a presentation, they learn hands-on activities, and then they go out at the request of teachers from all over the state. So a teacher can request a presentation, we'll hook them up with an ambassador, and then they will go to the school and do that. This is important because undergraduate students look like kids still. And an undergraduate student visiting a middle school or an elementary school classroom has a greater impact on that student than I would as an older person. And so we train these near-peer mentors to go out and show them that science is done in West Virginia, and you don't have to leave your state to do science if you're interested in doing science. So this impacts rural kids that don't have a lot of opportunities to, visit museums and things like that all the time. So these are some examples of presentations that we do, shows, we call them spot shows. We've just developed one called Space Weather. It's a drag, and it's really about satellites maintaining what happens to them, if they experience more drag with space weather happening. The Invisible Universe 2.0, that's a lot about the pulsar discovery and joining the Pulsar Search Collaboratory. You can see some here too. And we've got several on water research that goes on in the state too. Okay, and finally, I am a principal investigator on a project called the First Two Network. And this has really taken so much of my time and energy over the last 7 years it's been going on. But our goal is to improve the persistence of first-generation STEM students in college. So in West Virginia, at least, and it's based in West Virginia for us mostly, Kentucky as well. But here, if you do ACT surveys with high school students in West Virginia want to be STEM people at a higher percentage than the national average. And that's part of their culture in a way. They're rural students. We are, we love nature. And so as a high school student wanting to do something in science is likely, but our students don't make it through to the end with a degree. Only about less than 30% of our first generation students that start out as STEM students graduate with a STEM degree. So this is a problem, and Green Bank Observatory got involved with it because of our experience engaging students in research experiences. That's a high impact practice that builds that STEM identity, and we've seen lots of data to support that over the years. And so we got involved with this, and it is really a huge program in the state. It's been awarded lots of National Science Foundation money. But it's predominantly not based here at all. It's based at these colleges and institutions where people work together to try to improve the STEM culture or the academic success of their students by testing ideas. And so it's just a program that I've been privileged to be a part of, that the observatory allowed me to be a part of, that actually takes a lot of my time and will continue to after I retire at the end of this year. So we have some plans for future things, and we'll just tell you about them right now. We're working on proposal that probably won't get submitted before I retire, but it'll still be in the works when I do. And it's to do digital signal processing with kids, because we just did it this summer and it worked, right? We just had 14-year-olds build horns, and they did it and they were excited about it, and they collected data and they took them home, and hopefully they'll keep using them. So there's a website, and I'm going to just put the acronym up here on the board. I'm going to say it out loud for those of you on Zoom land. But if you were to Google DSPIRA, DSPIRA, that stands for Digital Signal Processing and Radio Astronomy. This was the original research experience for teachers program that engaged teachers in building these amplifiers and putting these horns together. WVU's created a lovely amplifier. I think it's the best one I've seen that we got a bunch made of, and we could get more made of. But if you Google that, you'll come to their website. You can join. They have a monthly meeting, and people from all over the country that are working with students to build these, or just, this is something you can just participate in as an individual. And you're already doing it, so you could share the cool stuff you're doing with the DSPIRA community there. But we'd like to take some of what was done with teachers and bring it and see if we could get some instrumentalists trained up in high school, maybe before they start becoming majors of things. That should say 2025, not 20,225. But we were given some money from the Bloomberg Foundation to hold a SETI teacher workshop next summer. So we're going to do that. And that'll be great to do something just with teachers, because then we can hang out in the lounge and have a good time at the end of the day, which you can't really do with kids. And we're working on an exhibit for the Science Center that would be centered on nanograv and gravitational waves and pulsars and things like that. Yeah. Oh, yeah. We just got this money too. We just got a small grant to do to help community college students get that research experience before they transition into four-year school. So we're building partnerships between community college STEM departments and nanograv institutions, and we'll be bringing them here for a week next summer too. So that's what we're up to in EPO in general. That's a lot. I talked really fast, but if you have any questions or want to start a discussion, please ask me. Happy to answer.
So in West Virginia,
Yeah.
in addition to this location, what are the other science career objectives for students that you're trying to point them at?
With this, this includes project that I'm a member of, any. So it has very little to do with being a radio astronomer, and it has to do with if you are a STEM major and you're a first generation college student, what are we going to do to help improve your success as a college
But
student?
my question is, after you've improved their success, where are they going to go in West Virginia?
Yeah, that is a great question, and something that people don't know that much about, but you can work with federal agencies here on biology type of research, or you can work in chemistry with the chemical companies here and chemical research.
But what are the centers of excellence in West Virginia?
Yeah, well, there's
Where or what? Are you saying where or what?
centers of excellence.
Where in West Virginia?
Yeah.
Or what in West Virginia, whichever you want to call
Yeah. Chemours, there's a lot of, in chemistry anyway, there are a lot of chemical industry companies that work with us as part of First Two. Of course, there's this place, but we don't hire that many people.
Well, here's one data point for you, because in the computer industry in West Virginia, in 2023, we had 1,009 jobs went unfilled.
Thank you. Yeah.
So there, and I know it's just in the computer, there's plenty of work out there in that.
We have a new plant being built in Morgantown related to hydrogen, creation of hydrogen fuel. And I don't know everything that's out there really, but it is true that in general, there are STEM jobs left unfilled here in the state, because people have the thought that they need to leave the state to get work, and that's not true, at least not in all STEM fields. So yeah, First Two Network's job is to get them through, although career connections is really, really important as well, and something that we need to work on more, I'm sure. Yeah.
You had mentioned your 2-week stint as a teacher back in the 80s.
Yeah.
Do they do that 2-week training camp anymore for teachers? Or is that last thing that you mentioned about?
The SETI workshop?
Yeah, is that the only thing left for teachers?
Well, yeah. And that's just because you kind of follow where the grant money is, I guess, because a lot of the things that I do are funded by external funds that we write grants for, like the Governor's STEM Institute's funded by the state of West Virginia, for example. But I'd love to do a teacher workshop again, because teachers bring their students back. It's a gift that keeps on giving past just that one interaction. So if we write that digital signal processing for kids, it will be for teachers and students.
I've noticed that shift though, away from the teaching the fish
Mm-hmm.
in the outreach and the education, to where it used to be all teach the teacher
Yeah,
and then let them go out.
Yeah.
But here over the few years, it's more geared towards let's teach the students.
mm-hmm.
I'm not a professional educator, so
Yeah.
there had to be something.
Yeah, I think it's just what a lot of the funding for any educational program comes through the National Science Foundation, and you just sort of you're a synergistic partner with what their priorities are in a way. And so the PSC became teachers and students, and then what happened was we don't have enough weeks in the summer. So if you keep doing what you're doing and then you're trying to do something else, where do you fit that in? And that's been a big problem with us. If we had more weeks, we would do more things. But yeah, I would love to do something again with teachers. And this teacher workshop next year with SETI, we got some funding to do it, and we're going to do it. It's only a week, but we're going to do it. And, I hope to write a successful proposal before I leave.
It might be interesting to do maybe another proposal to try to get a camp for radio astronomy teachers.
Yeah.
So that they can put it into their classroom.
Mm-hmm. Yeah. I think so. Those were really fun. We did those for years. They were the best, because teachers are fun to hang out with. They're more fun than kids.
I have a comment, if I could make one. I remember when I started college back in the 60s that the orientation day, they had people sitting in an auditorium, and they said the person on each side of you probably won't finish college. So
Yeah.
you mentioned that you have only a 30% completion rate. I'm thinking that might not be so bad. And I wondered if
It's
you
bad.
have any information compared to other colleges and how people just generally start out today. Freshmen, do they really finish?
Yeah, but if it is bad, because we need more STEM people, and we don't have enough STEM people, and people that really want to be STEM people shouldn't face that kind of an attitude from the professors to say, look to either side of you, half of you aren't going to make it, and that's the way we like it here in this university. We're over that. We're over that. It's not the students' fault. They have assets, and we need to work with those assets. Now, if you take classes and you're like, this is not for me, I don't like this, then absolutely don't be a STEM person. But helping students persist through obstacles that are created at the institutions is what we're after, and to get rid of those obstacles at the institutions, to change the system just a little bit so that students have a greater chance of succeeding. So yeah, it's wrong attitude. Yeah, that still exists out there. You're absolutely right. Tom, did you want to make a comment or question?
Yeah, I've mentored 2 students in the past 2 years on radio astronomy. I've got the papers, I'll give it to you.
Great.
I'll have them take a look. They were juniors, in high school. I'm looking for a project for next year for
Yeah.
a student, so I need to chat with you about that.
Okay, great. Yeah.
And then on the other side, the optical side,
Mhm.
I work with Georgia Tech and the Space Force. In the past 2 years, we've introduced over 6,000 kids to astronomy by having them use a telescope, Georgia Tech Space Force telescope on Maui.
That is so great. You know, when you collect your own photons, you're just changed forever.
That's right. It's
That's right.
just how quickly they move,
Yeah.
how much energy.
Yes, exactly. Exactly. That's great, Tom. I'm glad to hear that. I haven't seen him in a few years. I'm glad you're still at it. Other questions? Comments? Mhm.
Off topic.
Yeah.
Last year when we were here up on the GPT, we took pictures and they never came up on Flickr. Are they lost forever?
I'll ask Paul about that. Did he come up with us and take pictures? Was it
I
a staff
believe
person?
It was a staffer.
Let me ask about that, and I'll also ask if you can take pictures this year.